Assalamualaikum and hi. So, me and my friends, we are from AS1204I, and today we're going to make a video presentation about forensic science using chromatography. So, we going to explain about this topic from A to Z. So, I hope you guys enjoy. Assalamualaikum and hi. So, today I will be introducing you guys about chromatography in forensic science. So, forensic science is the application of scientific methods and techniques to investigate crimes. It helps forensic experts to examine evidence that collected from crime scenes such as blood, drugs, fingerprints, ink, and other chemical substance. So, one of the most important analytical technique used in forensic laboratories is chromatography. So, this technique allows scientists to separate and identify the different components of a mixture, making it too easier for scientists to determine what substances are present. So, chromatography plays a significant role in providing accurate scientific evidence that can support criminal investigations and court cases. So, what is chromatography? As we mentioned earlier, chromatography is a technique used to separate, identify, and analyze the component of a mixture. So how it works? It works using two phases, which is the stationary phases and the mobile phases. So for stationary phases, which remains fixed, and the mobile phase, it can be a liquid or gas. As the mobile phase moves through the stationary phase, the different substance in the sample travel at different speed because they interact differently with each phase. As a result, the mixture is separated into its individual components, which is this separation allows forensic scientists to identify unknown substance accurately. So I will tell the importance of chromatography in forensic science in the next slide. So in this slide, we will talk about importance of chromatography. So as we mentioned earlier, chromatography is an essential tool in forensic science because it helps scientists to identify and compare chemical substance that found in a crime scene. Like it's shown here, it can identify illegal drug, detect poisons and toxins, compare in forged document, analyze fire debris for accelerants, and last but not least, examine trace evidence from scenes. And one of the biggest advantages of chromatography actually is its ability to detect very small amount substance with high accuracy and reliability. Because of this, it provides strong scientific evidence that help investigators to solve a crime and support legal decisions in court. So, in conclusion, chromatography is a powerful analytical technique that plays a vital role in a modern forensic investigation.
My name is Mama Azim Akmal. So today I will explain the type of chromatography used in forensic science. Chromatography is an analytical technique used to spread, identify, and analyze the different components in a mixture. In forensic science, it helps investigators identify unknown substances collected from crime scenes. The most commonly used type is gas chromatography or GC. It is used to analyze volatile compounds, which are substances that evaporate easily. GC is commonly used to detect drugs, alcohol in blood, explosives, and residues from arson case. For better accuracy, GC is often combined with mass spectrometry, known as GCMS, to identify chemical more precisely. Another type is high performance liquid chromatography or HPLC. It is used for non-volatile compound which cannot be heated without breaking down. HPLC is commonly used to analyze poison, medicine, dyes, and biological sample. Thin layer chromatography or TLC is a simple and fast technique. It is mainly used to screen drug and compare inks or dyes before further laboratory analysis. Lastly, paper chromatography is used for simple separation such as comparing ink and dyes. Although it is less common today, it is still useful for basic forensic analysis. That's all from me. Thank you.
Hello, my name is Muhammad Nazidin Azman. For this part, I'm going to talk about application in forensic science. As you know, chromatography is widely used in forensic laboratories because it can separate and identify unknown substance with high accuracy. Some of its main applications includes, for the first one is drug analysis. One of the most common uses in identifying illegal drugs, such as cocaine, heroin, methamphetamine, and cannabis. Chromatography can also determine the purity of a drug and detect adulterants or cutting agents mixed with it. These informations help investigators identify the source of the drugs and support evidence in court. For the second one is toxicology. Forensic toxicologists analyze blood, urine, and tissue samples to detect alcohol, prescription drugs, or poisonous substance. This is important in case of suspected poisonings, drug overdose, or impaired driving. Techniques such as HPLC and GCMS are commonly used because they are highly sensitive and accurate. And for the third one is document examination. Paper chromatography is used to compare inks from different spans. Even if two inks are appears identical to the naked eye, chromatography can separate the pigments and reveal difference in their chemical composition. This helps determine whether a document has been altered, forged, or written using different spans. And for the fourth one is the fire investigation. Gas chromatography is used to detect flammable liquid such as petrol, diesel, and kerosene in fire debris. Finding this substance help investigators determine whether a fire was accidental or deliberately started. And for the last one is the explosive residue analysis. After an explosive, tiny amount of explosive chemicals may remain on clothing, vehicles, or nearby objects. Chromatography can identify this residue, helping investigators determine the type of explosives used and possible trace. Let's look at a simple example. Imagine a bank received an anonymous threatening letter. The police suspect that the letter was written by one of the three employees. Investigators collect the letter along with pen from each suspect. Small sample of ink are taken and analyzed using a paper chromatography. During the experiment, each ink separated into different colored pigment. The separate pigments from unique pattern called a chromatogram. When the chromatogram from the anonymous letter is compared with those from the suspect's pens, one employee's pen produced the same pattern. This strongly suggests that the same ink was used to write the letter. But this result alone does not prove who wrote the letter. It becomes valuable forensic evidence when combined with fingerprints, handwriting analysis, CCTV footage, and other evidence collected during the investigation. This is example show how chromatography help forensic scientists compare chemical evidence objectively and accurately.
Hi, my name is Ilmi bin Muhammad, and now I will explain the advantages and limitations of chromatography in forensic science. Firstly, chromatography is highly accurate and sensitive. It can detect even very small amounts of substance, making it useful for analyzing forensic evidence
such as drugs, poisons, or explosive residues. Secondly, chromatography can separate and identify different compounds in a complex mixture. This allows forensic scientists to obtain reliable results that can be used as evidence in court. However, chromatography also has some limitations. The equipment such as GCMS and HPLC is expensive and requires regular maintenance. In addition, trained personnel are needed to operate the instruments and interpret the results accurately. Another limitation is that sample preparation can be time-consuming, and some samples require special treatment before analysis. Overall, despite these limitations, chromatography remains one of the most important analytical techniques in forensic science because of its high accuracy, reliability, and ability to provide strong scientific evidence. That's all from me. Thank you.
Hi, my name is Adam Haris Haikal bin Kambul, and now I'm going to talk about future of forensic chromatography. So looking ahead, forensic chromatography is likely become significantly faster and much more accessible to the development of portable instrument. So instead of sending every sample to a centralized laboratory, investigator may be able to perform preliminary analysis directly at the crime scene itself. So this shift would substantially reduce overall investigation time and allow for more immediate decision making in the field. So another promising development on the horizon is the integration of artificial intelligence to analyze chromatograms. So AI system can help forensic scientists identify unknown substance more quickly and accurately by recognizing complex patterns in large amount of chemical data. So this technology has the potential to streamline the identification process and improve the reliability of result. So as criminals continue to develop new synthetic substance and compound, forensic scientists naturally need more advanced analytical technique to keep the pace. So ongoing improvement in chromatography technology will always allow for detection of increasingly smaller quantities of substance and the identification of newly emerging chemicals. So this continuous evolution is essential for maintaining effective forensic capabilities in ever changing the landscape. So to conclude everything, chromatography is an important analytical technique in forensic science. It helps forensic scientists separate, identify, and analyze different substances found in evidence, such as poison, drugs, and explosive residue. So because of its high accuracy and reliability, chromatography plays an important role in supporting the forensic investigation and providing the scientific evidence. So as the technology continue to develop, future improvements such as portable instrument and AI-assisted analysis are expected to make forensic chromatography even faster and more effective. So overall, chromatography will continue to be an essential tool in helping forensic scientists solving the cases and support the justice system. Thank you, that's all from us.